Hey! In the next two lessons of the Helm Lightning course, we will talk about three core components of Helm: charts, templates, and values. Let's start with charts. Chart is a packaging format of Helm. It's the top-level collection of files that defines your Kubernetes resources. It's similar to operating system packages, for example, RPM and deb packages contains all the files and scripts required to run some application on Linux. There are multiple ways to create a new chart. One of them is to run helm create chart name command. This command creates a new directory with a basic Helm chart inside. The problem with this command is that it creates a bit too many files for the beginner to understand. Another way to create a new Helm chart is to do it manually. Let's create a new directory called mkdev pgadmin. This directory will contain our Helm chart that deploys pgadmin for PostgreSQL database management. Each chart requires a chart.yaml file that sets some metadata. I need to set API version to v2, the latest version of Helm API. The name would be mkdev pgadmin and description is just a Helm chart for pgadmin. Next, I need to set the chart type. There are two types: application charts that are used to package Kubernetes applications, and library charts that only package various functions and help us. Library charts are on the advanced side of Helm usage and won't be covered in this course. For this chart, we will pick the application type. Finally, we need to set the chart version and an app version. App version is the version of the application your chart deploys. For example, we might get a new version of pgadmin, but we don't need to change any other files in the chart. For such cases, app version is used. After we have our chart YAML, it's time to define some templates. Helm expects all of your Kubernetes resources to be defined inside the templates directory. There is no limitation around how you name the files in this directory, neither there is a limit of how many resources you can define in a single file. Let's start by creating a deployment YAML with the following contents. As you can see, we don't really template anything. It's a pretty basic Kubernetes deployment with two environment variables and a publicly available pgadmin image. Installing the chart means that Helm will process our templates and apply them to the Kubernetes cluster. We can do that with the helm install command. This command requires two arguments: the name of the Helm release, pgadmin in this case, and the location of the chart, which is just a local directory where our chart.yaml is located. We will also pass the wait argument to tell Helm to wait for the pods of our deployment to enter the ready state. Let's run the command. We get a nice info about the status of our release. We can verify that our pgadmin is working by listing the running pods. I've mentioned something called Helm release. When you run Helm install, Helm doesn't simply apply your YAMLs, it also tracks what it has installed by creating a release. Release is an instance of your chart deployed to the cluster. You can deploy same chart multiple times, but with different configurations and different release names. For example, we could deploy two independent pgadmin installations for two different development teams, or we can test new version in a development release and then promote them to staging or production release. To list the releases, we can run Helm list. It shows us when application was deployed the last time and the current revision of the release. Every time we upgrade the release, it will increase the revision. Let's create another file with a very simple service definition. To upgrade the release, we can run helm upgrade pgadmin. Now we can forward the ports of the service to verify that pgadmin is running. This is looking good. Two more things about Helm releases that you should know. First, the way Helm tracks releases is by using Kubernetes secrets. If you run kubectl get secrets, we will see two secrets with the type helm.sh release v1. There is no other database or custom resources that Helm needs to operate, only those special secrets for release tracking. And second, we can easily roll back releases to the previous revision by using helm rollback command and passing the release name. If I run this command and check for the services, I see that there is no more pgadmin service in the list. This is because you've added it in the previous release revision that was then rolled back. With the simple chart format and a couple of commands to install, upgrade and roll back the releases, Helm becomes a very convenient tool to package and deploy applications to Kubernetes. But simply packaging YAML files is not enough. We want to parameterize our templates so that we can deploy slightly different configurations to different environments. We also want to reduce the duplication in our code and keep some things defined just once. For this, we are going to use templating features of Helm, as well as values files. This will be the topic of the next lesson.